Let's solve some MCQs from Similarity. These are previous year's board questions. Now the first question is that if triangle ABC is similar to triangle QRP, then the corresponding proportional sides are which of the following? So I have drawn a rough figure to represent the two similar triangles, triangle ABC and triangle QRP. So here we need to understand that similar triangles follow the naming convention, just the way congruent triangles were following naming convention. So when we say that triangle ABC is similar to QRP, it's not PQR, we need to understand that angle A, the first letter, will be equal to angle Q. Similarly, angle B will be equal to angle R, and angle C will be equal to angle P. So I've marked the angles with the same colors, which represents the corresponding angles. But anyway, here they are asking about corresponding proportional sides. So if I want to answer that, let me look at the order of the letters that they have written. So let's say the first triangle, the first two letters are AB, and from the second triangle, the first two letters are QR. So the first pair of corresponding sides must be AB and QR. So AB by QR, this ratio must be equal to, then I'm looking at the second and third letter, BC and RP. So BC by RP, and that will also be equal to the first and the third letter and the first and the third letter. So AC by QP. So these are the corresponding sides which are proportional. AB and QR, these are corresponding sides. Then BC and RP, AC and QP. If I look at the options, option number A is correct. So it follows what we have, AB by QR equals to BC by RP. Moving ahead, in the given diagram, the triangle ABC is similar to triangle DEF by which of the following axiom? So now here they have given in words, they have not written the similar symbol. So that means here the naming convention is not given to us. So we need to figure out which are the corresponding sides or angles. I can already see that there are these 90-degree angles given. Okay, so we have our corresponding angles which are equal. But about the sides, they have given some measurement of the sides. So let's figure out which pairs of sides are corresponding sides. So let's say that we have 3 and 4 centimeter, then 18 and 24 centimeter. So if I look at 3 centimeter by 18 centimeter, 3 by 18, it reduces to 1 by 6. And then if I am looking at 4 centimeter and 24 centimeter, 4 by 24 also reduces to 1 by 6. So I have two pairs of sides which are having the same ratio, or we have two pairs of corresponding sides which are proportional, and the angle between those pairs of sides are equal. So that means we have the SAS similarity criteria or SAS axiom. And if I wanted to write the triangles which are similar, I will say that triangle ABC is similar to triangle. So AB has a corresponding side with DE. So I will say DEF. And if I look at it, AB is corresponding to DE, then BC is corresponding to EF, and angle B is equal to angle E. Okay, so by SAS axiom, these two triangles are similar. Then the next MCQ. In the given diagram, triangle ABC is similar to triangle PQR. This is given, and AD by PS is equal to 3 by 8, then the value of AB is to PQ is which of the following? So from the fact that the larger two triangles ABC and PQR, they are similar, I can say that AB by PQ is equal to BC by QR, that is equal to AC by PR. Okay. Then they are saying that AD by PS is equal to 3 by 8. If I now look at the small triangle ABD and the small triangle PQS, what can I see? I can see that these angles are equal to 90-degree, angle D and angle S. And also because the two triangles are similar, I can say that angle B is equal to angle Q. From the fact that ABC is similar to PQR, angle B is equal to angle Q. So if I look at the smaller triangles, triangle ABD must be similar to triangle PQS by AA axiom. I have found out two pairs of corresponding sides that are equal. So from this pair of similar triangle ABD similar to PQS, I can say that AB by PQ must be equal to AD by PS. Now AD by PS is given as 3 by 8. So that means AB by PQ must also be 3 by 8, or in the ratio format it should be 3:8. So option C should be correct. Then the last question. Now this question again was from the year 2022. This format is not being continued right now, but anyway, in the main question there are some information given and there are four sub questions which are there, four MCQs which are related. So with the given information in the diagram, first question is that triangle similar to triangle ARQ is which of the following? So where is ARQ? We have ARQ over here. And it's given that this is parallel to this. It is given. So if we have triangle ARQ and we have AQ parallel to, this is point O. So OC parallel to AQ is given. Then I can easily say that ARQ will be similar to ORC, because ORC is the smaller triangle here. ORC, angle R is the common angle, and because OC is parallel to AQ, I can take one of these pairs of angles as corresponding angles. So ARQ is similar to ORC. If you look at the other options, there will not be enough information to say that ARQ is similar to any one of those triangles. Then the second question is asking, second question, that PQR is similar to BCR by which of the following axiom? Where is PQR? PQR is the larger triangle. So PQR is similar to BCR. So these two triangles are similar by which axiom? So again, what information do we have? We can see that angle R is a common angle for these two triangles. And again, because we know BC is parallel to QP, I can again take one of these angles, let's say this angle and this angle. These are pairs of corresponding angles. So I will have at least two pairs of angles which I can prove that are equal. And since two angles are equal, even the third pair of angles must be equal. So if I look at the options, option B is correct, which is AAA. AA, AAA, both are okay for this question. Now let's move ahead to question number 3, the third subpart. Question is asking that if QC is 6 centimeter CR is 4 centimeter, BR is 3 centimeter. The length of RP is what? So RP, this is the side. Alright, so to answer this question, I can either use similarity or I can use basic proportionality theorem. They're asking the length of PR, so if I'm able to find PB, then I can add with BR to find the entire length PR. So let's say that BP length is x centimeter. According to basic proportionality theorem, why can I use that theorem? I can say that in the larger triangle, I can see that BC is parallel to QP. So therefore the sides QR and PR will be divided in the same ratio. So I can say that CR by CQ will be equal to BR by BP. And if I plug in the values, 4 by 6 should be equal to 3 by x. Then if I cross multiply, 4x will be equal to 3 into 6. So x will be equal to 3 into 6 by 4. If I simplify it a little bit, this is 9 by 2, which is 4.5. So x is 4.5. So they were asking the length of RP. RP will be 4.5 plus 3, which is 7.5 centimeter. So option C is correct. And for the last part of the question, let's erase this. For the last part of the question, they're asking us that the ratio PQ is to BC is which of the following? So PQ is to BC. They're asking what is this ratio. Now we can answer this question by looking at a pair of similar triangles. So these two lengths are part of two triangles. Which are those triangles? The larger triangle PQR and the smaller triangle BCR. And again, previously somewhere we have proved that they are similar. So the ratio of corresponding sides can be written down. So we can write that from this I can say PQ by BC is equal to QR by CR, and that is equal to PR by BR. Okay, so QR, CR. Okay, if I look at this part of the ratio, QR by CR, QR is this entire length, which is 6 plus 4, 10 centimeter, and CR is this length, which is 4 centimeter. So PQ by BC is 10 by 4, which if I reduce, 5 by 2. So if I look at the options, it is option number C, 5:2.